Will be having a keynote session. The topic is Shaping the Future with Generative AI. Shri Vinod Khader, he is the Executive Director IBM. He is already here to talk. It's my pleasure to welcome Mr. Vinod Khader, a distinguished software engineering leader with 25 years of experience driving innovation and transformation in the tech industry. As the executive director at IBM Software Labs and Kochi location leader, he spearheads the development of the cutting edge Watson Orchestrate platform while leading global high performance engineering teams. With a proven track record in building agile, cloud native solutions and empowering teams to deliver impactful results, Mr. Khader brings invaluable insights to our panel discussion today. We welcome you, sir.
Thank you. So, she gave an intro already. I don't have to give another intro of myself. Just want to know the crowd. Are you all students or do we have somebody else from the industry here? I mean, I can see some other faces. Are you all faculty here or from the industry? Okay, so anybody who is practicing AI, those kind of elements? Okay, from different domains, right? So I made some slides. I'm not sure if I'll go through that because I made it thinking that it'll be a combination of industry practitioners and students and all that. If it is open, yeah, I'll go through that. So like she mentioned, right, IBM came to Kerala and Kochi around 3 years back, and we started building something we call as the software labs. So software labs is the area where we build our software products. So we build a lot of cutting edge new technology products from right here. If you see your campus, right, next building is the Lulu and the Brigade buildings. We operate from there. We build some of the latest technologies right from this campus. And when we see from our office, right, we can see your campus, hoping that some of the future technologies are going to be coming from campuses like this, right? So what I'm thinking is, if you have any questions in between, right, you can stop me and ask me questions also, or I can prompt you for that. We can try to make it interactive because it's already lunchtime. You may be looking forward for your lunch and you may be a bit tired also, right, with many sessions that would have happened already. So what I'm going to touch upon is, as a starting point, right, if you look at a lot of technologies that are happening today in the industry, if you look at some of the major companies and organizations that are driving these technologies, many of these are located in some specific areas in the world. And these specific areas, one thing that is common is there are certain universities and campuses around these areas. And why is it happening? And this is not something that has started to happen in India. I'm really hoping that these kind of technology events, tech summits will trigger that. But what's really happening is these companies, right, are spawned from campuses. Students who create an ecosystem, companies, smaller companies and bigger ones which are operating around in that area, and the students from different campuses, right, very smart ones, they come with their own ideas, they innovate and they build solutions and they spawn a lot of startups. If you look at the majority of the technology advancements that happened over the last couple of decades, right, I would say a big share of that came from around campuses, right? That is a change that should happen in India, and I'm hoping that universities like Jain University will start to trigger that revolution. So you should think about it. If you're in your first year, second year, you should look for something like in 6 years down the line. Are you building something that is driving the new wave of technology, right? So that's the opportunity in front of us. And there are many companies who are doing that. So think about it seriously. That is one thing that I would start with. If I move, right, let me get into AI space. So the last panel also, they were talking about when did AI start? It was back 50, 60 years back, 1960s, 1950s and all, right? So if you look at AI is not a new technology. It came to common people over the last 2-3 years, and that's where it is a big talking point these days. Until then, it used to be like, for example, right? In my school days, we used to regularly hear something in radio, TV, and all, right, and newspapers, where people used to say that our models are predicting that it may or may not rain tomorrow. So I'm saying two things here. One, the accuracy. So the prediction that is coming from the models is it may or may not rain, which is meaningless, right? But my point is, it used to be given by AI models. I'm talking about back in 20 years back, 40 years back, even 50 years back, weather prediction, wind prediction, a lot of other industrial predictions also used to be given by AI models. So AI modeling, which is the basis of AI, it all existed even decades back. The change that has happened now is this technology has gone to the common people now, to the society. Anybody here who hasn't used AI, like ChatGPT or any of the other tools, do you think that anybody here hasn't touched AI at all until now as a user? I would be surprised because all of you would have already, one way or the other, right, would have touched AI directly or indirectly. So there are two types of consumers in my point of view. One is a user who will be using AI. Second one is a practitioner who will be building it, right? So today, a lot of you would be users. What I would encourage you all would be to move from that side, the user side, to the practitioner side. You need to start to build things. And now since I'm talking mostly with students, right, what I would suggest you folks do is to go back and understand the technology, identify a smaller problem that is available around you. It could be in the society, in the ecosystem, or even within this college campus. And see if you can build a technology or if you can build something, an application using AI to solve that problem. It's not going to be easy. You're going to fail. You may not hit your targets at all to begin with, but that's a journey. If you do that right, that's the journey that will take you from the user bucket to the practitioner bucket. Think about it seriously, right? That is one thing. Now, what I'm talking about here is something called opportunities. I'm not going to spend a lot of time on opportunities because if you look at the Tesla that is outside, right? It is an outcome of AI also. That's an opportunity in the automobile industry. If you look at the mobile industry, if you look at medical industry, like a lot of hospitals are starting to use AI technology to predict diseases. One of the common use cases is cancer prediction. When you do a test for a patient, and if you submit that data into the system will do a prediction saying that is it malignant or benign. Two types of cancers, right? And what could be the root cause for that? Systems can do predictions like that. There are plenty of domains. I wouldn't think that there is any domain which is not going to be using AI from here on. So those are the opportunities. But it's also coming up with a lot of risk. What are the risks? The fundamental perception of risk is coming from the fact that, let me use the same example that I used for medical and cancer, right? Okay, let me not take a heavy cancer thing. Let me take a smaller, little more better example, right? Because if I were to ask you, right, if you were in a position meeting a doctor about cancer, that is not the right conversation, right? So let me take a better example wherein you have a little bit of pain and you want to diagnose whether it's a fracture or not. And if you're going to be using a system to determine that, right? Now, what will you prefer? Go and see a doctor and doctor giving a suggestion whether it's a fracture or not, or talking to a system and system is telling you what you should do next. What do you prefer? Then I will have to go back to cancer. Can you conclude? Okay, what will you prefer then? Consulting a doctor or consulting a system? Google. Okay, but eventually the most of the times, right, what people answer is I prefer to consult a doctor because you are talking to a human compared to a system. Your trust level typically is higher when you're talking to a human, right? And that's our current state. And if AI has to succeed, it has to overcome that state. it has to generate confidence in people. People will have to become confident about these systems. So trust is a major element. That's a big risk. Compliance, trust, and trust is going to be, and I'll come to that in more detail. Second one is there are a bunch of challenges in implementing AI and making it successful. I'll talk about some of those now. So that's a topic that I'll cover in the next 15 minutes, and I can take questions from you all. On the question, right, one thing that will come to our mind is if this system, the AI system, will have some level of trust issues and challenges, will it succeed? That is a typical question that comes to people's mind, right? So a lot of data points that I'm going to be talking about is based on a study that was done last year. And in this study, close to 400 industry leaders were interviewed from around 16 different domains. So what I mean by domains is healthcare, banking, retail, aerospace, whatever, right? So these kind of domains, 16 domains, and also from 6 different geographies, continents or countries, right? So some of these studies are coming from that. And in those studies, one thing that is coming out very solid is 82% of these leaders believe that Gen AI will exceed, so their probability of embracing Gen AI in the next few years is much higher, even if it is bringing some level of risk. What does that mean? What that means is all these leaders are going to be adopting AI, even if there is some risk, because they believe that the advantages of that is much higher compared to the risk that is involved. End of the day, it's a weighing, right? You weigh the advantages and the risk associated, but when they do that, they believe that they're going to embrace AI because the value is so high. And we see that, right? Even if AI is going to be giving you some wrong answers, you still go for it because you believe that majority that you're getting is valuable. It's the same thing, right? Now, this is the same state. If you look at 2024 and 2025, 2025, what I'm going to show here is more like an aspiration. You understand what I mean by aspiration, right? That is where I want to be, but I don't know whether I can reach there. Aspiration. Like many of you will be thinking that I want to be in a great company, I want to innovate, I want to do something great. That is aspiration. You got to do something to get there. So if you look at 2024, if you see those three, right? Let me explain what it is. Experimenting means I'm trying out AI. I don't know whether I'll be using it or not. The second one is I'm doing some scaling and optimizing, which means I did some experiments. I'm happy about it. I'm going to try it against a valid use case and see if it can really solve the problem. That is the second stage. Third one is innovating. I could find success already, and I'm accelerating with that. I'm expanding further. So if you see, right, today, close to 70% are in a state where they believe that they need to go to that state. But if you look at next year, where their aspiration is, more than 90% of the people are thinking that they need to implement AI in their real use cases, more and more and more. That is the aspiration. But for that, there are plenty of challenges, and how to do that is the biggest question that they have. So it could be too early for you, but if you want to do your own startup, say 4 to 5 years down the line, you need to be starting with some seeding now, right? So you need to think about it. What can I do a few years down the line if you want to go in that direction? Now, where is artificial intelligence moving towards? And actually, it's a very tricky one because what I see today now, on 27th of Jan, standing here, it could become totally irrelevant a year from now. That is a pace at which technology is moving today. I'll give you an example. I mentioned, right, we are developing something called Watson X platform from this building right here, IBM building. We are developing those platforms right here from this campus, and we are selling it to customers across the world. And I'm talking about one of the products that we're building using generative AI as the ground platform. Beneath that, in 2 years, we re-architected it 3 times. I'm not sure if you are able to understand what I mean by that, but somebody who's been in the industry for a long time will understand that that is very uncommon. If I take my example many years back when I started working in this area, if I learn a technology, I can leverage that learning for the next 6 years or 8 years. And then I learn something new. Today, the world has moved on. I don't have that kind of a luxury. I learn something now, I have to relearn something in July and again relearn in Jan or Feb. That's the pace at which technology is changing. So, whatever I'm going to be saying here may not be valid after a year or two. But today, as of today, the AI domain is moving into something called multi-agent orchestration. The last speaker here spoke about agents. If you know agents, great. I'll define that in a very simple way in a couple of lines. It is much complex than that. But in a simple level, what it means is, it is an autonomous system which can understand what you want and do it for you. It is heavily loaded. It covers a lot of things. For a system to understand what you want is understanding your intent. So it should be able to understand your intent and do it for you. And the other keyword there is autonomous. Autonomous means a system that doesn't need any help. It can understand you and do it for you independently, without you doing anything in between. And that is totally a different concept altogether. So that is an agent. An agent is an expert. Like you can have one expert, like the example that I mentioned, right? There's a lot of lab activities going on in the medical area. Samples, right? You take tissue samples and you give it for test. And from that results, you make out whether it's a cancer or not, or if it is something else or not. You do a lot of deterministic activities based on samples, right? One agent could be an expert in that area where it knows, given a sample data, it knows whether it can predict with X% accuracy, 80% confidence. I'm saying that I have 80% confidence that this is malignant and it is already spreading. I have 92% confidence that this is benign and there is nothing much to worry about it, right? That is an agent, a system that knows what it's doing and can understand the input and autonomously do it. And that is most important. Autonomous means it doesn't need human help. That's an agent. But we are beyond that now. What I'm talking about here is multi-agent orchestration. You know what it means? Think about a situation where you want to go for a vacation and you ask a system, where should I go for my next vacation and when should I go? If I ask, let me not pick her each time, right? Let me pick you. If I ask you, where should I go for my next vacation and where should I go? How will you do that? What are the things that will come into your mind? My interest. Yeah, where did I go before? Yeah. Which is a place that I haven't been before. Yes, right. Then?
And are you married?
Yeah, so, okay. So one bucket of my details, my interest and my details. What else?
A lot of things. Then probably cost is also an...
Cost is a good element, yeah. So which place will be more cost appropriate?
Yes.
The system has to determine.
Right.
Other things like weather, right? For example, based on my interest, should I go to a cold place or a warm place? And if it is a cold place, should I go in summer or winter? So there are multiple parameters. And the date that the system is deciding what is going to be the weather in that place at that point in time. You see what I mean? This is how we think, right? These are all things that the system has to think. Now there are multiple agents involved in this kind of a system. Why? Because there is a system that can go and check my profile and figure out where did I go last, my travel history, whatever. There is a system that can go to my social media profiles and all and figure out what are the things that I am interested in. A third agent, let me start using the word agent. The third agent can go and check if I'm married or not, how many kids I have, what is more appropriate for me, right? Where do I travel? How do I travel generally? Another agent can go and check, determine the places. Another agent can go check the weather, right? These are all specialist activities. One agent cannot do everything. So you need multiple agents. Now, can you have all these agents working independently and arrive at a solution? No. Like he mentioned, right? You need to collect all this info and you need to process it together and then iterate, refine, and then take a decision. This is exactly what an AI system will also be doing, which means you have multiple agents, expert agents, and you need a system where it can talk to each other and arrive at a decision. You see what I mean? That is called multi-agent orchestration. Now, think about the last word that I used, autonomous. Imagine if all these agents are talking to each other and taking that decision without you getting involved at all. That's where we are heading towards. So that is called multi-agent orchestration systems. So there is something called React. We call it React. It is your ability to reason and act on that, and then iterate on that. You can Google about it. You can get a lot of white papers around it on what is the React paradigm and the React different systems built around it. But that's how that system is going to be working. That is where we are moving towards. And these agentic systems can decide who means which agent should take care of this, do this activity. It will determine, like there could be 10 agents who are capable of understanding your profile and your interest. Now, out of those 10 agents, like for example, there are 10 people here and all 10 are capable of going and figuring out what Vinod is interested in. Now, if I'm an orchestrator, agent orchestrator, and I'm talking about autonomous systems here, okay, not people, I should be able to pick, should I pick him or him? That is decided by the system. And all decisions are taken by the system. You see what I mean? That is the direction towards the technology is moving now. Majority of the organizations are building platforms which are capable of doing this. Is it foolproof? Not really, not yet. But it could be a matter of time. So that's a glimpse of where the technology is moving towards. Now, one thing is here, right, I mentioned, how do we get there? How do we accelerate on this journey? And there are certain challenges towards it. So let me move towards the challenges now. The number one challenge in this one is skilling. And you see a number there, right? 5% to 35% to question mark. What it means is, typically if you look at this industry, if you look at corporates, right? Like I mentioned, this study was taken through 400 industry leaders across 16 domains. The average amount of reskilling required for their employees on a given year, an average is typically 5%. You need to reskill 5% of your employees every year. And that's a routine thing. But the moment AI came in and Gen AI came in, it just went up from 5% to 35% already. You need to reskill 35% of your people for you to be successful. And that percentage is still moving higher. What does it mean? Is the prediction is that, like, if you look at it, right, 35 years back, when computers came, it was optional. Now, can you imagine if you don't know how to operate a computer and survive in this world? If you're a working professional, it's going to be very tough. I'm not talking about a programmer, developer, software engineer here. I'm talking about any industry. You go to any industry, if you don't know how to operate a computer, it is impossible. The prediction in the industry is that over the next 10 years or 15 years, that's going to be a reality for AI also. So, like I mentioned at the beginning, there are two types of personas here. One is a user, somebody who uses AI. The second part is a practitioner, somebody who builds it, somebody who is building such systems. A lot of engineers here, future engineers, should be thriving or targeting the later one, practitioners, right? You should be building such systems. That's the future. So, AI skills are non-negotiable. That's very important. The second one is today we have experts, right? We have experts, for example, even if you look at software engineers or any other domain areas, within each industry there are domain experts. Somebody is specialized in finance. Somebody is specialized in automobile. Somebody could be specialized in some other domain, right? Like retail, stuff like that. So the prediction is that over the next few years, there will be a lot of agents who are specialized in specific domains. Now, we also have people who are specialized in specific domains, right? Now, all these people who are working, professionals, they need to now learn to work with agents. So, agent is like your colleague to whom you may delegate some work, or agent may even delegate work to you also back. It may take some decisions and want you to review that and approve it. You see what I mean? So that's the level at which we'll be moving, and that's the prediction. So a lot of companies will have to now train their employees to work in that kind of an environment, an ecosystem where humans and agents will be working together. But reskilling is extremely important. For the reason why I mentioned reskilling again is because technology is moving at such a rapid pace that what you learn today may not be relevant in a year from now. So you need to be able to reskill yourself and learn new things. And that's extremely important. The second one is this one, my topic actually was infrastructure and data, but I actually saw one reel yesterday from Jain University where somebody got a Tesla car and they put a Insta reel about that Tesla thing. You folks would have seen it, right? The Jain ad about the Tesla one. So I got interested and I added a Tesla, sort of a car technology thing over here. The context that I'm trying to say here is, if you look at that car, right, it is technology-driven vehicle. Compared to the traditional technologies where you wouldn't have your traditional technology, your fuel injectors and all those kind of things, right? It's not there. There is no potentially spark plug or fuel injectors and all. It's a technology-driven vehicle. Now think about it. Technology is changing every 6 months or a year or 2 years. And in 1 year or 2 years, technology will totally change. Now, will you buy a car, like an expensive one like that, wherein the technology is outdated within 6 months or a year, and then it's not funny anymore? Will you invest your money in such a vehicle? You will not, right? So as a manufacturer, if I'm Tesla or if I'm some other manufacturer, and I'm producing that kind of a vehicle for consumers, like you all, right? I need to make sure that whatever technology advancements are happening in the industry can be given to that vehicle also. And that vehicle should also be kept up to date with the latest technology changes. How do I do that? Because I'm manufacturing that vehicle somewhere, I'm selling it, somebody is using it in some place, and within that car, the technology has to be upgraded frequently. And people today, you may not be ready to wait for 6 months also. Or you may not be ready to wait for 1 year to take your car for a routine service to get that upgrade technology. You wouldn't prefer that, right? When iPhone is coming in or a new model of your phone is coming in, you run, buy the new phone. Why? It isn't because your current phone is not working, but you want to upgrade, right? So companies will have to make sure that the infrastructure underneath, right, is ready to cater to that kind of a need. And companies who doesn't adapt to that kind of a situation may not be able to survive. And that's a big change in the industry today. So today's customers may not be ready to buy a car, and just because I bought it, not have the latest technology for the next 10 years. No, I don't think today's people will be ready to accept that. The next one is very important. This is the regulations and ethics and trust and all, right? The first example that we were talking about, whether you go and visit a human person and get an input, or in your travel example, maybe you're okay to get that advice from an agent. Yeah. But in your medical profession, right, you may not be ready. If you're a patient, you may not prefer today to go to an agent, rather you go to a doctor, right? And that is also because of trust. And this is a new technology area, so a lot of policies and compliance regulations are not in place. And that is slowly coming out. So if you look at it, Europe has come with regulations, Brazil, Canada, India has the draft regulations already, more are coming out. Recently, there was a meeting wherein the Kerala government was saying that they are formulating adding the AI policy within the IT policy. So they are forming regulations and bringing it in. And that's extremely important because once that happens, the industry will align to those regulations and policies, and that's when the trust will start to build up. right? So that's an important thing. Now, I mentioned earlier, right? 82% of the leaders today, companies today, believe that even if it is risky, they will go for AI because the value, the benefits that they're getting is so high. Out of that 82 or even the 100%, 69% of the executives today believe that they will get some fines. You know what I mean by fines, right? Some penalties. Because they are going to be implementing AI. And they are okay with it. Because the value that they're getting is much higher that they are okay with it. But they also believe that when the regulatory frameworks are going to be coming in, right, that will help reduce these fines and things like that and have better control over those systems. So this is what the study is saying, which means people are going to be moving ahead with the technology, but we need to have the regulatory frameworks coming in. The second one is, can we use Gen AI itself to predict these kind of violations and correct itself? Can we use Gen AI itself to correct itself from making mistakes? And that's a very interesting area too. So there are a lot of technology aspects down here. Like I can talk about a couple of items over here. Okay, one is explainable AI. That's a very important thing, explainable AI. Like she mentioned, right, if she has a lab test and she has to go to a doctor, like she'll go and Google also. So that is like you need to understand why, if you're having a medicine or if you're doing a surgery on your body, right, you need to understand why you're doing it. You need to understand. And that is normal tendency, right? Explainable AI means if an AI system is taking a decision, ability of that system or the agents or the system, overall system, to communicate and tell you how did it arrive at that answer or the solution. Typically, it's a black box, right? You talk to a system and it tells you something, but it doesn't tell you how did it arrive at that answer. What is the path that it took? And which data was considered? Which data was part of the process to arrive at that decision? There are tools in place for that. That is explainable AI. There is another one called drift. If you know about how these systems work, right, it is based on something called models. Statistics models is what it used to be earlier. Now there are a lot of machine learning, deep learning, and beyond. Foundation models and large language models, small language models, different models are there in place. You can read about it. It's a very fascinating area, scientific area. So what happens is when a model is created, like humans, right, you train the model with some data. So you have a lot of, if it is medical, you get a lot of medical data and you pump that data into that model and train the model. And train the model to an extent where you have 90% confidence and then you use that model for real-time activities. What if over a period in time, the real data is changing and it is not anymore matching with the data which was used to train that model? Now you can imagine what will happen, right? The model will give wrong answers because it was trained, like you studied something and in your exam you're getting out of syllabus questions. Right? Obviously, you have to write something. It's an exam. You have time, so you will end up writing wrong things. That is exactly what a model is going to be doing. It was trained for something, but the actual question that is coming in is different, or the data that is coming in is different. It will make mistakes. It is called drift, what I mentioned over there. That thing is called, that particular process is called drift. So there are mechanisms where you can identify drift and rebase it. Do retraining with the new data and avoid drift. So each and every point that I mentioned here, there are ways to address it. And that is how you make your AI more dependable and meaningful. You can read about some of these elements deeply. The last one is cost. Many of you would have heard about LLMs, right? Large language models. These are large models where you need something called GPUs. You need thousands and thousands of GPUs to train these models. But you may not need that kind of LLMs in all cases. You can even go with small language models, smaller models, which you can do within smaller systems. So there are multiple ways in which you can reduce cost. And a lot of people believe that AI funding should be self-funded, which also would mean that Your AI system should be able to reduce your cost of that particular system itself so that you can put more money for AI. It should become self-funding projects. So these are all the concepts that are coming in. Now, probably this is a little more meaningful for students. I put the other slides together because, as I mentioned at the beginning, right, my understanding was that there'll be practitioners and students and it will be a mixed crowd. Since it is predominantly students, I would recommend a couple of things, or rather 3-4 things. One is this technology is changing very fast. If you see yourself as a technologist a few years down the line, and to be a practitioner a few years down the line, you need to learn to learn. You need to learn to learn and relearn. Whatever you're learning, you need to unlearn sometimes and learn new things and keep up to date with the market. What are the new technologies that is coming in? And how can you learn and relearn and keep pace with the technology changes? That will definitely give you an edge, number one. Number two is the third point. Whatever you learn, right, around you, identify smaller problems and try to build a solution using AI to solve that problem. And it's going to be a tough journey to start with because you wouldn't know how to proceed. But that's the beauty and that's the learning. But once you get a grip on it, right, your journey is going to be much faster. So when you look for a job or if you're aspiring to build something on your own, you should take that journey now. You don't need to wait for your engineering to complete or something. You should start to think about it probably in your first year or second year. The other element is not everybody can be inventors. Not everybody can go and create and invent a new technology. It's not easy, right? But many times what can be practically done is you can become a fast follower. Do you understand what I mean by fast follower? Somebody had an idea and they are inventing, but you don't waste time. Within a few weeks or a month or 2 months, you go and understand what they invented and you try to understand it and you try to practice it or you try to build the same. That's a fast follower, right? For example, now agentic AI is coming or multi-agent orchestration kind of concepts are coming. These can be things that you can build on your laptop, by the way. Using technologies like Dockers and containers and all that, you can build mini agentic architectures within your laptop. It is just about starting with it. The last one is, I'm hoping that with such initiatives, Jain University can start also an ecosystem where they can bring in specialists from outside and get your best students in and then create an ecosystem where you can do hackathons and create something out of it, right? If we do something like that, it can really ignite things. With that, I'll stop. And if you have any questions, I can take. I think they are in a hurry, so 1 or 2 questions. No, that means they need to go and have lunch. That's what it means.
Okay, what an incredible session we have just had. We sincerely appreciate the time, effort, and knowledge you have shared with us today, sir. We are truly grateful for the opportunity to learn from you. Once again, thank you for the wonderful session. Let's show our appreciation with a big round of applause. As a token of appreciation, we would like to present a memento to you, sir. I would like to invite Mr. Govindas Menon to hand over the memento to Shri Vinod Khader, Executive Director, IBM.